few weeks ago, I made a video showing how it's possible to crash an iPhone with a little microcontroller board like this ESP32S3. I ran a program on it called Sour Apple that could spoof Bluetooth pairing requests, and if you can get enough of those to show up on an iPhone, at the time it was able to crash the device. Now, since that video, I actually made one of these little boards to make testing this a lot easier. So it's using the same ESP32S3 Mini on the back, but it's connected up to this Nugget dev board, which has a nice screen and some buttons. And I'm running a modified version of a program called Apple Juice. It differs from Sour Apple in that you can select what kind of device you want to spoof. So in a previous video, I showed how this works. Since that previous video, I've added these two other options, which is an extended attack. So you can do sort of longer range. I think it's mostly sending like Apple TV pairing requests, which have a longer range, or you can do a random spam attack, which just goes through all of them. So to quickly show kind of what I'm talking about here, we're going to press up on the D-pad on the random spam, and pretty quickly there you're seeing we're getting some pop-ups. There's beats. Keep dismissing these. These will just keep coming up. So you can imagine if you were out and about somewhere and you've seen all of these pop-ups coming up, you wouldn't have a clue what was going on. And it's enough to kind of disrupt your sort of normal use of the phone. Now this week I actually heard about a project called Wall of Flippers that is designed to detect when Flipper Zero devices are doing this BLE spam attack. Obviously, I don't have a Flipper Zero. I've made this Nugget dev board with the S3 Mini to do this attack, just to sort of prove it's possible with a cheaper microcontroller. In this video, I want to basically try to build a BLE spam detector that works on the ESP32S3 Mini. So these have the same board. This one's obviously sending Bluetooth packets, but my guess is that if it can send Bluetooth signals, it can probably also monitor for Bluetooth signals around it. So yeah, that's what we're going to try in this video. To make that even easier, when Cody was sending me this kit, so Cody from Redia seen one of my videos and wanted to sort of support in a way and send out a little dev kit. He sent the board and all of the stuff I needed to make one of these. He actually sent a second Nugget dev board as well. So we should be able to make something that looks very like this, but is for detecting spam rather than creating spam chaos. Okay, great. We have our new Nugget board with the nice little S3 Nugget on the back. I pre-flashed this board with the Detector software, the like prototype Detector software. Obviously, because this board is exactly the same spec, I was able to test it on this one before building this sort of separate board. But this is my first time plugging in this board, so we're going to find out if the buttons work and the NeoPixel works and the screen. This is a little bit nerve-wracking, but anyway, let's power up the board and see what happens. Okay, cool, nice. Right, the screen is working and our NeoPixel is working. Thank goodness for that. Great. Okay, so this is your first look at the UI for the Nugget BLE detector. We've got our nice little cat. Nothing is happening right now on the device. If we press up, it should start scanning for us. And essentially how the program is going to work is it will do a 60-second period of scans, and it will do 10-second scans at a time. So with a little pause in between. So you have about a minute of detection time, and it can keep looping over and over and over. But anyway, it's probably easier to explain if we press up. So we press up, and nice, okay, cool. This is cool. So we've got the Bluetooth symbol above the cat. That means we're scanning, and you can see that we actually restarted the board there. I don't know what happened, but we've got this little number here, which is U and 8, which is unique devices. So we found 8 unique devices. Then you can see that some of those devices got moved into the safe list, which means we have found those devices more than once in separate scans. We want to put a threshold on the number of unique devices that can flood our scan at one time. So if all of a sudden I turn on the spam randomizer here, we're going to see unique devices going absolutely crazy, and it will go, once it goes over 17, this thing will tell us that it thinks there's a spam attack happening. So let's try that out. Let's just try that out. So I've got another power cable here, and we're going to plug in power to the BLE Spam. So again, I sort of showed this earlier in the video. Let's just go to random spam. We'll start it. And you can see immediately we're getting some new unique devices. 11, 12, 13, 14, 15, 16. Let's see if we can get it to go over 17. Okay, there we go. So we're now up quite high. It's starting to go even faster. So our little cat is very worried now about the number of random packets, and it's exceeded the 17. So that's why we've got the red NeoPixel and the sort of changed UI. If I reset the board, I have added a little bit of a function here to customize the max devices. So say you go out somewhere a bit more public and you want to increase the number of sort of max devices around you that you're happy to sort of accept. So I'd say, like, let's put it up to 30. So we can do 30 and then start our scan. And now our unique devices, we're going to find the same ones again, just the ones around us. We won't hit the threshold and sort of cause everything to go red unless there's 30 unique devices flooding us at a time. So that's a way that you can sort of modify this for your own environment around you, and also if you're out and about with this as well. I've had a lot of fun putting this little project together. I do think there's room for improvement in the future, perhaps doing something similar to the way the Wall of Flippers project works, sort of extracting the actual device ID out of the Bluetooth packet metadata. I haven't tried that yet. But for now, if you want to check the project out in the current state, you can go to the GitHub repo link in the description. I definitely recommend, if you haven't got one of these dev boards, to pick one up from Redia. There's a link to their website as well. It's really good fun putting this little project together and doing all the soldering and making your own little programs for it. But if you do just have the microcontroller on its own, the project will run on that. You just have to look in the serial terminal to sort of monitor what's going on. But yeah, thanks so much for watching this video. I really hope to see you again soon.